we are going to see the experiment of interface experiments with 8085. 8085 is a 8-bit microprocessor kit along with the interfacing experiment of analog and digital to analog controller. Okay, for digital to analog input, we are generating the triangular wave here, but in hardware side I have shown you the square wave, triangular wave and sawtooth waveform. Then now analog to digital output, we can see the for analog input we can see the variations in LED lights. Okay, LED lights, if it's glow it is 1, and if it's not glow it is 0. Okay, and we need the 8085 microprocessor kit, opcode sheet, DAC interface board and ADC interface board. Okay, so this is the algorithm for DAC. We have to start the program. Get the first input, this is a printing mistake, first input from the lookup table, set the counter in C register, out the data in DAC port. Okay, then we have to increment the lookup table address, increment the count value. If the carry is equal to 0, that is C register is equal to 0, we have to jump start. If no carry, we have to set the out data, then we can stop the program. For analog to digital output, we have to start the program, set the ADC control word to the accumulator, then load the input value in the accumulator, output the data from analog to digital output port. Okay, and now the outputs are taken digital form, that is LED lights only. Then store the result, stop the program. First program we can see the analog output, digital to analog converter, load immediate. Okay, load the immediate data of 8110, immediate memory address to HL register pair, and move immediately 41 data to C register. Move this memory, okay, memory content to accumulator and output the data. Okay, we are assigning the output port. Then increment the memory pointer, and memory pointer means it will move to the 8111. Okay, and then we have to decrement the number of values in the counter port and jump on no zero loop. Again and again we can get the loop. Then we have to move to the direct program first. Okay, this lookup table is stored here for triangular waveform. Okay, that's why we can vary the waveform to up and low. We can see in the mouse direction. Okay, up and low, like that triangular waveform will generate. So then for analog to digital, if we give analog to digital channel, then we have to initialize the accumulator value directly to 00. Then we can get the output port C8, then by or logically or the value with accumulator and ALE signal. Okay, then output the port control word to ADC control register. We have to create no operation and logically AND with accumulator and reset the ALE signal. Okay, and then output the control word of ADC through this port C8, then moving the control word to word of 10 to accumulator. Then we have to create the output code, output the control word to ADC controller. Then we are initializing the ADC ports. Okay, then end of the conversion signal we have to give input logically and then jump on no zero to loop, then increment the digital signal. Okay, then we have to initialize this address of 8200 immediate to the HL pair. Then control word we are moving into accumulator, then move the input from B to A, then logically and with OF value, then we can rotate left through the carry. Okay, because there is a 8-bit there will be, therefore we just rotate left to the carry, then moving the accumulator value to L register and moving the memory pointer to accumulator, then moving the B data to A data logically and the OF value. Okay, then with accumulator, then move that accumulator value to L register. We can get the output 00, jump to start. Okay, until the program starting address we have to move, we have to again and again we can get the output, then halt the program. Okay, we can see the running of the program. Please wait. We can see the running of this microprocessor program. we are going to see the 8085 processor kit running. We have to press A, okay, A for giving the starting address, and then we can type the program that such like MVI comma A comma 04, here MVI B comma 05. Then we have to click enter, okay. Just like we have to type the program, and after that when we complete the program we can give after that we have to press that reset button, okay. Please see, press this reset button for running the program, okay. Please wait. We have to press the reset button, then we have to enter go, okay, go and starting address. Then after executing we can see the output, okay, output in our record space. Thank you. Now we are going to see the digital to analog output. This is the interface, okay, that we have connected. This is the interface we can see, and this is connected to the microprocessor using RS-232 cable, and CRO is connected to the port 1 and 2, okay. This is the for positive I have given as 1, and negative I have given in the second port, okay. Now we can see the running of the program. See, now the program is executing. We can see the square waveform output in the CRO, okay. This is the way we can convert the analog to digital to analog output, okay. We can see the output of triangular waveform. Now after I have given this instruction to execute, we can see the output in the CRO. This is the output we obtained in the CRO for triangular waveform. We can see the output of digital to analog output for sawtooth waveform. Now after executing we can see the output in CRO. After executing, this is the sawtooth waveform we have obtained after typing the program for digital to analog output. Thank you, students. Now we can see the output for analog to digital. See here, this is the interface. Now by fully reducing the kit, when we on, it shows here no LEDs glow. Then if we vary some light, some potentiometer, we can see the light glow. See, now I am varying, and now I am pressing the key. Then I can see the variation of light LSB to MSB. If I fully vary the potentiometer, we can see the full light glow. See, we can see that our light is varying fully. Here only one light is not glowing. This is due to the loose connection only. So by varying this potentiometer, we can get various output. Thank you, students.